Welcome to Kishore's Neet Padasala. In this video, we will see the apparent weight of a man in the lift concept. Okay. Before going to that concept, we will see what are the common forces in nature. One force is the gravitational force, which is mg, mass into acceleration due to gravity. Another one is the tension force. Another one is the contact force. There are two contact force. One is the frictional force. Another one is the normal reaction. See, normal reaction is the force which is always perpendicular to the surface. See, for example, if you see this diagram, normal reaction is always perpendicular to the surface, and frictional force is always in the direction opposite to the motion. And there is another one force which is the spring force. Okay, now let us see the apparent weight of a man in lift concept. Before moving to that, I would like to say one formula. See that net force is equal to me. This formula you remember. See, since side is in positive sign, this side is also must always be in positive sign. Okay, this is the thing you must remember. Okay, now let us move on for this question. For this concept. The man is standing on the floor. Okay, we learned that normal reaction is always perpendicular to the surface, so normal reaction is n. Here the normal reaction is nothing but the apparent weight of the man. Okay, normal reaction is the apparent weight. The gravitational force of the man acts downwards, so mg. Net force is n minus mg, that is equal to ma. But the lifted at rest they have given, so n is equal to mg since acceleration is 0. Okay, now let us see the next case 2. Let us resolve the forces. First, normal force is perpendicular to the surface. Next, the weight of the man, that is the gravitational force, is acting. Since it is moving in the upward direction, I have said that net force is equal to ma. Since this side is positive, this side must also be positive. So see that lift is moving upward, so more force is in the upward direction. So I am writing n as first minus the downward force, gravitational force. Why I am writing n as plus? To get positive value, since the other side of the equation is positive, is equal to ma. N is equal to m into g plus a. Now this n, this is the apparent weight of the man in the lift moving upward. Now let us see the next case moving downwards. The same normal reaction, gravitational force acting downward. Now you see that this is a downward direction. I have said that net force is equal to ma. Since it is in the moving downwards, the downward force is greater, so only the lift is moving downwards. So downward force minus the upward force is equal to ma. So n is equal to m into g minus e. This is the apparent weight of the man in the lift moving downwards. Free fall is nothing but acceleration is equal to acceleration due to gravity. Okay, so n is free fall is nothing but it is also moving downward only. Okay, free fall is nothing but the one which is falling freely under the acceleration due to gravity g. Okay, now let us resolve the forces. Upward force is n, downward force is mg. Net force is equal to ma. Okay, net force, since it is moving in the downward direction, downward force is more, so I am first writing the downward force mg minus n is equal to ma. Okay, but here a is g, that is the free fall condition, so mg minus n is equal to m. A, instead of a I am substituting g get cancelled, so n is equal to 0. So apparent weight is 0, which means that in case of free fall, the man experiences the weightlessness. Okay, so always remember that net force is equal to ma. If it is the downward direction, then downward force minus upward force is equal to ma. If it is in the upward direction, then upward force is greater, so upward force minus downward force is equal to ma. I hope you like this concept. If you like this concept, please subscribe Kishore's Neet Padasala. Thank you.